Physicists have detected a high-energy neutrino particle that crashed into Earth in 2023. Scientists at UMass Amherst gave the theory that this particle came from a primordial black hole, which would be able to tell us about the conditions of the early universe. This week, we talked to one of the authors of the study and Mr. Heaney about what this actually means.
So, my understanding, the interesting part of this discovery of this high-energy neutrino and the model being proposed to explain that is that this is coming from not a black hole formed in that same manner from the collapse of a large mass star. We're talking about black holes that were formed in the very, very, very early universe, a primordial black hole or primordial material. And the difference between these and kind of the classical version of a Schwarzschild black hole is the mass. They both have incredibly high densities, light can escape, but because the mass of these primordially formed black holes is less, then through this process of Hawking radiation and their mass decreasing, they could decay at a much more frequently. And we would see evidence of that in these high energy neutrinos that would be passing through the universe, like the one that was recently, captured in 2023, I think.
Okay, so if this neutrino would come from an exploding black hole, but I think that would tell us a lot of things about the origin of our universe. Precisely because these black holes would form in the early universe. So that would tell us how the universe worked right after the Big Bang. It would have very deep implications.
So in terms of the possible sources for that high energy neutrino, I think that the model that's being put forward is a really interesting one. And I think one of the things that we talk about in class is that the way that you test a model is you make a prediction with it and you look for evidence. You make a prediction and you see if that prediction comes true or not. So I think that it's an interesting model in the sense that it's a possible explanation, and we should be able to test it by continuing to look for similar high energy neutrinos. If that model is accurate, then we should see them on a much greater rate.
So far, I think our explanation, where we basically propose that this high energy neutrino that we detected comes from a very special type of black hole that exploded relatively close to Earth, is the only one that seems to be consistent with all the observations and all what we know so far.
But I think that it's an interesting model. It's a possible model, and it's one that we can test. And to me, that's the most important part, is that you can then test to see if this is something that holds up.
So the next step would be to look for a photon signal coming from an exploding black hole and see if this is consistent with this explanation.
Thank you for watching, and if you'd like to know more about this topic, the link to the paper itself will be in the description.